In this first program, it was to get to know LabVIEW. In LabVIEW, we have two sections. In the first one, the physical elements are shown. On the other side, that is the block diagram, everything that is not seen with the naked eye is placed, but this part makes everything we want physically done. In this first program, we have a constant that in this case we write hello world, and this constant is attached to an output that is the string, and by running the program on the physical elements you can see what we put in the constant. Now, in the next program, two graphs managed by LabVIEW were used. What this program does is what we will have a thermometer that will measure the temperature in degrees Fahrenheit, and here in the block diagram we put the operation that must be performed to convert the degrees Fahrenheit to degrees Celsius. So, when they are converted to degrees Celsius, that value will be reflected to the waveform chart. This graph represents all the values at the exact moment, and in turn the value can be seen this box since it is also linked to the output of the operation. As you can see. To know the exact moment, this timer is placed, which is the one that measures time. But in the waveform graph, it works in another way. This will give you the graph once the program stops, as you can see. Here is the result.
Okay, so let's start with this presentation. We're going to present the simulations made in LabVIEW. I'm going to present the 2.1, that is while loop. This simulation is about to control a thermometer. The temperature of the thermometer controller is in Fahrenheit, and the temperature of another that is controlled is in Celsius. What the program is doing is that it takes the value you choose from the first thermometer. Then subtract 32, the result is multiplied by 5/9. After this, the result is already given in Celsius degrees. The while loop function is making the loop as long as the function remains true. That's why the process doesn't stop working. The stop button is going to be false in this loop. So when you press it, the process will stop working because it's a false declaration. Okay, so let's start with the 2.2. The 2.2 is the for loop. For this simulation, we're going to put the whole simulation inside a loop, which is in counting to 5. The process starts the simulation with a random number that is going to be saved as an accumulator. After this, the simulation will repeat the random number, already chosen one by one with a single delay that you are choosing. Okay, so you can see it. It's counting the random number and the rate is saving it. So you can see the repeating numbers are repeating until 9. Okay, so let's continue with the 2.3. It is case structure. This is the case structure, and for this simulation, we're going to use a thermometer one more time. But the simulation will measure Celsius and Fahrenheit degrees, depending the case you choose. If the numeric number is 0, the simulation is going to measure from Fahrenheit to Fahrenheit. So the data is going to pass as the input. When is 1, the measure is going to be from Fahrenheit to Celsius. So the simulation inside the case will change the equation. And the numeric data is 2, the second thermometer will remain in 78 because the data is printed in the thermometer as default. The simulation will continue as long as you press the stop button. Another thing you can do is change the time to read the values between the measures.
Okay, now I'm going to explain the 2.0. This simulation is for shift registers. Here, for example, we have this indicator we have the random numbers, and these shift registers is going to make a sum of every random number, and we were going to divide and we will have the average. So if we run this, here we have our random numbers, and here we have our average from the sum of the first random numbers. And here we have our bottom stop. This is a while loop, and if we press the button stop, it will stop all the simulation. Then we have the 2.5 is the state machine. This one we have here a case. So when we run the simulation, this process are going to run and until we press the button stop. So here we have the indicator in which process do we have the cases.
Okay, so let's continue with the data types. For the next simulation, we're going to print data required by the user. For example, integer, you can print only entire numbers, for example, 4. And in the floating point, we can print decimal numbers, for example, 1.4. So in the Boolean, only turn on or turn off a switch, as you can see. In the string function, this print only text. So for example, hello. And in the array, you select the position and the number you want to say. For example, in the first position, we're going to write the number 1. In the second position, the number 2. In the third, the 3. In the last one, a 4. So as you can see, this is an order. So let's continue with the next one.
Well, then we have our arrays. The arrays function works like this. We have here our indicator to in the values that we want in the array. And here we have our output. For example, if I want to I want to put value of 2, here of 4, here of 6, here of 8, and 10. We observe that the graphics that we have here, the values are for the array in position 0 is 2, in the position 1 is 4, in the position 2 is 6, the position 3 is 8, and the position 4 is 10. This block indicates the number of positions that our arrays have. For example, here we have 5 data, and for example, here on our index and element, this one indicates the position of the array, as we have here 0, 1, 2, 3, and 4. So we have only these 5 positions. And for example, if I select the position 3, that is this one, it's going to print our value of 8, that is this one. And then we go to the cluster. Here, for example, in the cluster we have only one function. As you can see in the block diagram, this inputs only shows one block. And for example, we have here the name, the last name, we put here our age, and this switch is going to mark if we are male or female. In this case, female. We run it and print the values over here. But as we can see, cluster we only have one block, and these ones are different blocks. We can put also these blocks into one as a cluster like the first one. Then we have the local variables. Here, for example, we have 3 while loops. In this one, we have to input a value, and it's going to print it over here. And then we have here another input, and it's going to print over here another values. And the local variables works like, for example, if we have a loop here and we have another loop here, but with the same input, we only select the local variable and we put it like this, and also in this. So the value that we in here is going to out it over here.
Well, in this case, I'm going to talk about data flow. In this case, you can see the program. In this case, this is an example of data flow for multiple code segments. And here we have the inputs and the outputs, their controls, and well, the output. This is a random function that is going to send a random number, and I select these values for the inputs. You can select the values that you want, or I select this. Well, we're going to see how the data flow flows through the wires. Let's start. As you can see, the red dots indicate the data flow, and they advance some first than others that you can see. That this all has a process. First, starting the inputs that the values flow to the wires and arrive to the add. After that, the output goes to the rest, and this gives us a result when we have the random number 2. Let's see again. You can see how the values are run, and then we get the output. The same in this case. We have the values and the input as an output. This enter to the next step, and we get the output again. And this is all for this part. Well, I'm going to explain how to use the tool palette. You have to know where you can find it. You have to go to view. This is going to appear this list. You have to select tools palette, and it's going to appear this that I have here. Now, in this moment, we have activated the automatic tool selection, and you can do things like that, or like that, or actually you can do you can change the size like this. You can turn on the LED or not and move the switch. Also, you can go to block diagram. You can do connections to wires, for example, here to here, something like that. Or is incorrect in this. And you can do it without necessity to select one by one. But if you deactivate that, you have to select, for example, in this, you can do now this, but you don't do it, you can change the size of this. You have to select this for do it, and if you want to change the name, you have to select the part of the edit text, or if you want to do connection, you have to select it. Actually, you can select this part to change the color for something like this, but it's better if you select this part because you don't have to select by one the different options that has the tool palette.
This program consists of converting degrees Fahrenheit to degrees Celsius. But the main thing about this program is to know how debugging tools work. First, to notice that your program has an error is when you see the arrow to run the broken program. When you click the debugging tools, they will tell you what the problem is and a small description of why it is wrong. And when you click it, it will send you directly to the problem. As in this case, the problem is that I didn't put how long the time will work. When placing that variable, it already marks that the error is corrected, as you can see. For something else, the debugging tools are used to be able to see the exact number that are circulating. For example, to see this, click on the focus on the part of the block diagram. That is this. And you can already see that is the receiving and what is each connection commands.